So 50% of my time is Chief Talking Officer, which is this right now, and the other 50% of my time is Chief Technology Officer. We operate now at VMware an office of the CTO, which is about 200 people, I think, in direct line, and then several hundred outside that sits on top of now an R&D organization that's in excess of 9,000 people at VMware. VMware's become quite big. I joined 8 years ago. Some of you remember me back then and even from before. And we've grown quite dramatically in that time. When I joined, we were about 6,000 people. We're now 24,000 people. We've gone from a couple of $1 billion to over $10 billion worth of revenue, and now market cap that puts us in the big leagues at over $80 billion. So it's an interesting space to be. The other thing is, at the office of the CTO, we are at VMware famous for innovation, apparently. We keep getting voted in the top 4 or 5 most innovative companies in the world, which is quite a thing to bear as one of the 4 CTOs at VMware. We have a global CTO, Ray, and then 3 of us, 1 per region. And so what I wanted to share with you today was a little insight into what we're seeing going on in the marketplace with regards to application architectures and infrastructure, and then talk a little bit about security and touch on some of the stuff and some of the topics that actually we put together for Pat to talk about at RSA recently as well. So I'll take you through some of those, and then we'll get into a Q&A session. So VMware's vision, very simply, has been for 5 or 6 years the same, and will continue to be this until, whoever knows, which is essentially, we would like our customers to be able to deliver any application from any cloud to any device. And the any cloud story has been developing quite strongly. Some of you may have noticed recently we announced with Microsoft VMware on Azure. So now there's pretty much every cloud in the world you can now run a VMware workload on and essentially achieve what we've been aiming at, which is a globally consistent operating system and a globally consistent operating model for our customers, enabling to have choice between different clouds. And then obviously the ability to do different applications. There's a whole bunch of stuff there about Kubernetes and other things I'm not going to talk about today. But that's not cool anymore, apparently, because if you go to any of the really cool, trendy conferences with people with much better beards and much tighter jeans than me, and much younger than me, it's all about PaaS and like serverless, right, dude? Isn't it? That's the thing, yeah? And if you're not talking about PaaS and serverless, then you're not cool, apparently. Well, this is where the first word in my title comes in. Now, normally when I do this in different countries, I translate that word, but I found out that actually it's a word that's pretty much the same in most European languages, and that's chromatography. So chromatography, some of you will remember from chemistry, if you did chemistry at school, hopefully, right? And chromatography was where you got that little liquid and you put it on the magic paper, and then over a period of time, that liquid split itself out into all the pretty colors or all the component parts. That's what's happening with applications. And I don't think people have realized. What people think is that we replatform stuff. That's what we've trained as an industry to do, replatform. Right? You start off with something on a mainframe, we replatform it to the mini computer, to x86, and then now, because we've gone through mini computers and x86, and now cloud's the next thing, obviously the thing to do is to replatform everything to cloud, right? Isn't that correct? Well, unless you're government, in which case you've left everything on the mainframe and then just added accretively other platforms to it. It's not. What's actually happening is you're not going to end up putting everything into one of these boxes. And repeatedly I go to customers where I see them say, okay, we're going to put everything in PaaS. We're going to PaaS. We're all in on PaaS. We're going to put and replatform all our applications to PaaS. No, you're not. And you're not going to put everything in IaaS either. And not everything's going to be SaaS, because there's trade-offs in this stack. The higher up the stack you go, the faster it is to adopt, but the more sticky it is. Sticky is a polite marketing word for lock-in. Okay? But essentially, if you extrapolate this as a scientist to extremes, if we had as one of our larger customers 3,000 applications and we did those all as SaaS, that might be great until you have to do something regarding compliance or data location or GDPR or whatever, or backup or DR or you name it, across 3,000 different SaaS vendors. Or you could go the other extreme and run everything on the same operating system on the same box. That doesn't work either. There's a blended mix. And just to make it a little more complicated, as an industry, we've added extra layers to this. So now it's not just SaaS, PaaS, and IaaS. It's also CaaS and FaaS, just to make it fun. So now you've got infrastructure as a service, rent a whole virtual machine. Containers as a service, what, you rent a whole virtual machine, how extravagant, I just rent parts of one. Then you've got PaaS, which is, you dirty your hands with containers. I just turn it with an application and let the platform worry about the containers. To FaaS, which is, you run a whole program, how extravagant. I just run a part of a program when I need to. To SaaS, which is, you write programs. That's disgusting. I just buy them. And so when I go and talk to people now, and I talk to CIOs, the realization and the dawning is that what they're not going to do is get all of their applications and put them into one of these. What they're realizing is they're going to have a strategy for every single one of these boxes going forwards. And it's not just 5 boxes, folks. It's more than that, because it's 10 boxes. Because you're going to have answers for all of these, both on and off premises. So now it's not just one, it's 10 different destinations. And what's fun is you don't take one of your applications and put it into one of these boxes. You take one of your applications and smear it across these boxes, and then you take another application and smear that across the boxes, and so on and so forth. And so if I give you an idea of a normal application that we're working on and deploying with our customers right now, large German car manufacturer, which is something you won't be able to say in 10 years, but that's fun. What they're doing is they are using functions as a service on premises with some specific OEM gateways, essentially Zigbee to IP gateways, that sit there and read stock levels, where a particular car is in the process, how many tires they've got, etc., at a periodic basis. Now, obviously, you don't need to monitor how many tires you've got in a factory 30 times a second. Every half an hour is fine, even every hour. But other bits, where is the car in the process? Yes, I need to monitor that 3 times a second because it's moving. So they use functions as a service there to periodically run different bits of code to then write some data down to an on-premises SQL server. 2 boxes. Stay with me. They then have some really cool, funky stuff they've written in containers, because that's the cool way to do it nowadays, guys, that does what we in the old school call ETL, which is pull data out of that database, process it, and then pushes it out to Amazon S3, which is IaaS. So that's 4 boxes now, folks. Where they then have platform as a service running in Google, because they're using Cloud Foundry in Google, to look at that S3 database and then build dashboards and real-time stuff for management. 6 boxes now. What's great is, because they've got a subset of data of what's going on in their factory and their production process in S3 now, sat publicly, they can sub-permission that, so their suppliers can now see parts of that, so they can understand to do a bit more predictive in-time analysis of how they're going to ship stuff into the factory. So that's 6.5 boxes. That's a normal app. That's a normal app for our customers. Now, if I'd gone back 10 years and asked someone to do that, they would have looked at the nasty box they had sitting in the corner that was running SAP or whatever, or WebLogic or DB2, and gone, you're kidding me, we can't do any of that, that's impossible. Now that's normal. Now what I want you to understand and think about is, does a large perimeter firewall for their data center make any sense at all in this model? No. And so when we look at where we're going with applications, how the architecture is becoming, chromatography, the reason why I use it is because that's exactly what's happening. What used to be a big lump on a server in a data center behind a firewall is now being smeared. Vertically in the stack, bits of it go to the best place for execution. FaaS, CAS, PaaS, IaaS, etc. And then it's being smeared horizontally in the infrastructure, all the way out to endpoints, to mobile phones, to the hands of the users. And then worse than that, we now have the wonderful phenomenon of citizen developers, which is the new shadow IT, by the way. And a citizen developer is someone in your management team or sales team or whoever who is now getting the data and then has realized there's some other cool thing they can get with some app on their phone that integrates them with some other piece of data somewhere else on the internet that you have no idea what it is, and they then somehow link it together with an API, and now they're pulling your data into someone else's cloud and giving them some really cool, funky dashboard, and suddenly stuff's gone way beyond anything you've got control over. And that used to be done on Excel spreadsheets, which people kind of tried to control with locking down laptops and stuff, but now we've gone way beyond that too. So thinking about security changes fundamentally as we go forward. And there's the famous saying, you know, the network is the computer, if you remember that from the Sundays. Well, now we're into the application as a network, and it's been said 1 million times by 1 million people, but it's no more true now than ever before. It really, really is now a challenge for our customers to understand that pretty much everything they do is not about that server in a data center. So it's why for the last 4 or 5 years at VMware, we've been working on edge technologies, distributed, integrated, software-defined networks, software-defined storage, essentially building a distributable platform that will run anywhere. And so now for our customers, I can provide them with a software-defined data center. Here comes the marketing slide. Just warning people. I will as we do this. That's the only one. We have been building what I call an operating system for data centers, which is now an operating system for clouds, which is something that gives you globally consistent operations at every point in this chain. So whether you're doing it in a public cloud, such as AWS or IBM or VMware, or VMware Cloud on AWS or Azure, it's exactly the same operations model, the same security model, the same network with NSX that you're doing at the edge, that you're doing in your core data centers. And so whether you're building new style applications, old style applications, cloud native applications, 12-factor applications, microservices, doesn't really matter. The platform that it sits on is a consistent infrastructure. And so now, I'll give you the perfect example. We deal with retailers a lot, and a lot of our edge work actually has been driven by two main, I suppose there's two main industries have been the early drivers of edge: military and retail. You know, so military want to push more and more technology to the edge. Retail have realized that they need to do more and more in their stores. And you know, you can add on to that telcos pushing technology out through the network, et cetera, which has really come as a much later phase, and a whole bunch of other things, but really they drove it for me. Retail was a great one. I'm not going to talk about military, apart from, you know, we do it for submarines and helicopters and things, but the retail one's great, because with retail, the people that run branch infrastructure usually are nothing to do with the IT department, which is part of the biggest problem, okay? And if you go to an average retailer today and go and stand and look at the store infrastructure, I'd hate to call it the server room, because it isn't. It's a 22U, 9U, whatever it is, rack stuffed under some manager's desk at the back. In there's a massive old Cisco router that someone's paying thousands of pounds a month to maintain, probably. There's kit with Compact written on it to give you an idea of how old it is. There's a particular box there which has a flashing light on it and a machine that goes ping that runs their point-of-sale system that no one knows what it does, but we just have to keep it and look after it. So when you go to that team that manages that infrastructure, as one of our retailers did, it was brilliant. They said, yeah, what we're doing is we're rolling out a new application and we want to put 3 containers in every store. No word of a lie, the guy from the store team said, what size are the boxes? Thinking they meant plastic containers, right? And I'm not making this up, because that's how detached they were from, not reality, but from where and how things were being built. What I'm providing and what we're looking at now is they will drop into that store instead a hyperconverged piece of infrastructure, which may be very small. It might be 2 E200s, you know, Supermicro E200s with a Raspberry Pi stuck on top of it for the SAN witness. Not a lot of money. In there will be the ability to run VMs, to run desktops for the management, to run containers. Also, there'll be a virtualized SD-WAN endpoint, so we don't worry about that either. It's one self-contained box. These things already exist. We're delivering them for a lot of people. But what that means is actually, it's not about infrastructure, it's about applications. So as an application developer, I can now sit at the top and go, right, I'd like to develop my application. I'm going to have some VMs in this blueprint that are deployed over here in this cloud. I'm going to have some access to some data services over there in that cloud. I'm going to put 2 VMs in every single one of our data centers, and we're going to have 5 containers spun up in every store. API, click, next, next, go, done. That's the point. So when we look at consistent infrastructure and ultimately consistent operations, what you're aiming for is a consistent developer experience. And so really, if you get to the bottom line of what we're at VMware right now, it is providing that globally consistent infrastructure that then provides a globally consistent operations model that then provides a consistent developer experience. But at the same time, if we're developing applications differently, then security becomes very different very fast too. And as I alluded to before, the way we think about security has to change. And it has to change dramatically. So what's wrong with security? Well, the first thing that's wrong with security is this hyper-focus on security threats. We seem to be absolutely focused on chasing down threats. We organize everything we do as an industry into two major buckets, right? It's either reactive, this is all about firefighting, anti-malware, host intrusion prevention, endpoint detection and response, etc. And then there's proactive, which is, fire prevention, hardening, patching, segmentation, app control, encryption, two-factor, all those kind of things that we should be doing. If you look at the focus in budget, response, effort, time in most security organizations, it kind of looks like this. The bulk of our investment is, and this is also in time and innovation, is predominantly focused on the reactive. We're hyper-focused, we chase threats. We're underinvested in preventative, this is for most organizations, and as an industry. And even from an innovation standpoint, it's like we've been standing still for the last decade. Patching, process whitelisting, encryption, this hasn't experienced a wave of innovation in the last 10 years. It's just sort of best practice and people and process. It's not actually moved on. 80% of enterprise IT's investment in security goes into reactive. 72% of current venture capital investment in security startups is in reactive security model stuff. However, what has the biggest impact on reducing risk is to flip it, as I think you all probably realize, and I don't need to tell you as we go through this model. Dollar for dollar, we have a far greater impact on reducing risk with preventative measures than we do with reactive ones. I think everyone knows that, whether it's medicine, whether it's anything. And in fact, we're not the only ones saying so. It's not often I stand up and quote Gartner, but today I'm going to. When you look at essentially the Gartner framework for protecting workloads, they stack-ranked all the controls you could apply to a protected workload in order of how much risk it addresses. The items that address the most risk, all preventative. And as we know, an ounce of prevention is worth a pound of cure. And this is exactly where we're underinvested. However, all this stuff that claims to be application aware typically isn't. You come from a security industry that thinks application aware is, we do deep packet inspection. It's not application aware, I can look at a header. I don't know what that packet's doing or where it's going. Okay, you would be hard-pressed to find at a security show, you'd be hard-pressed to find a security product on the show floor that doesn't claim to be application aware. You see, it doesn't translate to what actually composes this application. If you think about what I just said, the previous piece, application awareness is about how an application is composed, how it interacts with the infrastructure, its topology, its intended behavior. That's what's needed, not just protocol analyzers on a network link. So on our perimeters at the moment, we dissect traffic going to the internet to gain some kind of application context, but that's not sufficient to solve the problem inside our environment. This is like having a city and saying you're going to prevent fraud by inspecting people as they walk down the street on certain checkpoints. Okay, it's not going to happen. It might have happened in medieval times when we had walls around our city and everyone who came in and out of the city we could check. But now our society doesn't work like that. So we see acts of security theater in the physical world all the time that I know all of you laugh at as we go through various bits of our journeys. But how much security theater do you see in IT? How much times do you think people are missing the forest for the trees by looking at this? Understanding an application means I have to see the whole thing, not just that small part of it. The other thing here is your most important security product won't be a security product. So if you go and ask any large enterprise how many server vendors they have, they'll tell you 2, right? Maybe 3. Why 2? To keep them each honest. I'll use HP and Dell. How many networking vendors do you have? Well, we're mainly Cisco, but we've got a bit of Palo Alto or whatever coming in just to keep them honest. How many security vendors do you have? Well, on average, about 100. Usually more like that, like 150 or something. Is that right? I mean, look at it. This is the security NASCAR slide as it stands right now for our industry. It's so small that I can't read it standing here. So I don't know how any of you guys are coping, but you can have a look later on when we send the deck out. These are the security products we use to protect our critical applications and data. The big problem isn't that there's too many products to choose from. No, I've not got a problem with that. It's that there's too many products to manage and reconcile. The average organization uses between 50 to 100 of these products. That's 100 products to deploy and manage. That's 100 different policies and policy boundaries to reconcile. And policy management is one of the biggest problems when it comes to security. The security of applications and data are hurt far more by misconfiguration and misalignments of 100 different applications than by something that we didn't do. It's complexity that kills us, and it's complexity that is the weakness for our organizations. But what if solving some of these problems didn't involve adding more products, more agents, more appliances? What if it leveraged what we already own? What if it opened the opportunity to get rid of a ton of these products? And this brings us to really the greatest security opportunity before us, which is to leverage cloud and virtual infrastructure as an industry rather than simply securing cloud and virtual infrastructure. We marvel as an industry about how the cloud, both private and public, has given us unique properties like elasticity, automobility, simplicity. We've used these properties to change how we build, deliver, and manage our applications, as you saw me talk about earlier. But it's time to start looking at the capabilities of the platform for security as well. What we're doing is we're doing everything in a new sexy way around software-defined data centers. But what we're doing is we're applying old security principles and old security rules to that model. If I see another security vendor coming out trying to install agents in VMs, I think I'm going to kill myself, right? It's not the way to do things, okay? What we can do here is we can give visibility and control without more agents, no more appliances, and without bolt-on controls. So our focus at VMware has been on leveraging the virtual infrastructure to dramatically reduce the attack surface. And by doing so, use our position to provide you with a clear understanding of the applications running on top of us. It's all about its intent. And to lock it down to ensure good rather than chase bad, to make security intrinsic rather than bolt on. And that's more than embedding just our old controls into a switch. That would be simply integrated security. What we're doing, integrated security makes security a distributed service within the platform. It rethinks the model of leveraging the power of the cloud to secure the cloud. If the law of gravity no longer applies, don't define yourself by it. We've changed the rules with cloud. We've changed the rules with virtualized infrastructure. We've changed the rules with virtualized networking. We've changed the rules with virtualized storage. We need to change the rules about how we do security. So what does this shift in thinking look like? Well, let's consider how this would change something as basic as a firewall, right? We all understand enterprise firewalls, hopefully. But using the principles I laid out and the unique properties of virtualization, you end up with something that you don't add to your environment, you already have it. It is your environment. You now use this new distributed service provided by your environment to see your infrastructure through the lens of the applications running on top of it. What you do is through the application you understand what known good is. I know all the components of my application. Through machine learning, I can understand what those components do, how they talk to each other. By collecting similar components and information on similar components from all of our customers and 50 million VMs worldwide, I can do unbelievable understanding of how things behave. Then, what I can do is I can start to say things such as, hang on a second, that thing there is talking to a box it never talked to before. That thing there is encrypting its file system. It's never encrypted its file system before. I can spot from understanding how and what normally communicates with each other. I get to a world of known good. And that world of known good means that both the network level and at the host level, I can understand an application and apply policy, not just in isolation. A known good is the difference between golf and tennis. If you're playing golf, it's very different to playing tennis, right? Hopefully you've worked that one out by this age, okay? Now, tennis, what you're doing is you're playing against different opponents on a weekly basis, and those opponents can hit the ball at you in thousands of different ways. Millions, if you consider all the possible trajectories, spin, etc., of that ball. So you can spend your life perfecting the ability to deal with and respond to a rapidly changing threat. Known good is the opposite. That's like playing golf. Where I stand in relation to the ball never changes. I can tune that to my own liking. And I'm continually practicing how I perfectly hit that ball every single time, because I know the parameters of the world I live in. I might move to a different golf course and learn different golf courses, but ultimately I'm working off a base of known good. It's a very, very different way of thinking. And so it's because we understand this both at the host and the network level that we can do this. Somehow with my machine, is it on there? Okay, there we go. So in this model, because what we're doing is we're putting security into the hypervisor, security monitoring and management into the hypervisor, then connecting those hypervisors to all the other hypervisors, and then understanding the network, the security, the compute. Because what we're in is a unique position. As a hypervisor, I see everything, okay? Because I am the virtual world that everything lives in. So I see every piece of network traffic, but also I see every piece of storage traffic. I see every piece of memory traffic. I see every CPU traffic. I see everything. So I am in what we call that Goldilocks zone for security to understand what's going on. So we know the host because we booted it. More importantly, we're outside the host because we're not stuck inside an OS. And more importantly, we're everywhere. We are a distributed service. We're running the network, we're running the storage, we're running the compute, we're running it across multiple clouds. We can apply a policy that stays and lives with an operating system, with a host, with a guest, no matter where that ends up in the infrastructure. In the old world, if I took a VM and wanted to move it from one data center to another, that was a nightmare of networking security. I'd have to tell the network team we were moving a VM. And they'd scream at you about trunk ports and PIX firewall rules and all this other kind of stuff, right? In this world, I drag and drop the VM from one cloud to another. Its security goes with it. Its networking goes with it. Its policy stays with it. I don't have to do anything. More importantly, we sit holistically with global machine learning and learn from all the hosts. This comes together into what we call a service-defined or service-driven firewall. So an enterprise firewall makes sense for north-south traffic, right? Where we've defined perimeters and users going to the internet and comms and extend beyond our applications. But it's the wrong tool for the job inside our environments. Inside, we need to understand the composition, topology, and intended behavior of our application and lock them down. Least privilege for your entire application, for everything that it does. This is an internal firewall. It's an east-west firewall as well as a north-south firewall, but it's not a firewall. It's intrinsic in what we're doing in the system. And it's not just taking north-south concepts and sticking them inside the firewall, inside our hypervisor either. It's leveraging the unique capabilities of the cloud to make it even better than we possibly could be. So what do we need to do? As an industry, we need to drive and invest in prevention. We had a customer spoke at RSA for us in the keynote, and she was a bit bolder, and she said, fire your security team and don't hire them back until they've built an application, which was kind of interesting. It's a bit strong. I'm not going to say that myself is the best way to do it. But while you're at it, make your application teams visit the SOC, the Security Operations Center, and see what a challenge it is to secure the attacks based on what they've built. Okay? I mean, the prevention one's pretty obvious, right? Do I buy and spend loads more money on firemen, or do I work on making houses a little less flammable? It's not difficult to understand. Focus on applications. This is probably, for me, as a technologist and an architect, the biggest shift. Applications were something we ran on top of the infrastructure that we secured, right? Now it's different. Applications are what we're all about. Applications are bigger and more complex than ever before. Applications are what we secure. The infrastructure should not be something we have to worry about. The infrastructure should be there to support securing applications, not the other way around. So when you're looking at those other security vendors or the security world, think about how many of them are talking about securing infrastructure. For us, we need to make security intrinsic, built into absolutely everything that we do. Built into the hypervisor, built into the network, built into the compute, built into the storage. So no, VMware is not a security vendor. We don't sell security software. What we do is we make sure that security is in everything that we do with our platform, and we make sure that we enable others to add security features on top of that. And with that, that's my 20 minutes up, and I thank you very much.